Okay, now let's see the next part. If we already get the LSP in the synchronized database, how to do the root calculation. And if the database is ready, then the router will, according to the SPF algorithm, to calculate the shortest path and to reach the destination. And in this algorithm, all the router will make themselves to become the root. And according to the link cost value, and choose the shortest path. That means the cost value, the whole cost value smallest, and select to become the best path. And in the ISIS, the SPF algorithm runs in separate level 1 and level 2 database. Okay, so like this topology, we have 5 routers to connect with each other, and all the link has the cost value. Then everyone will calculate the routing information. For example, about the route 1. Route 1, how to reach route to route B, we have multiple link, right? The smallest is the cost value 1. And how to reach the route C, we also have multiple link here and here, and maybe here, right? So according to the cost value, the best one is A, B, E, and C, because the total cost value is 4. So select the best one. And one by one, finally, if route A want to reach route B, directly connect with each other. If you want to reach route E, the best next hope is route B. So according to the cost value, finally the topology will become a tree. There is no loop. Of course, about the route D, if route D want to reach route B, they will calculate a new path again. And finally, to get the tree, and the root is route D itself. So this is the main process about SPF algorithm. And in this step, in ISIS, the special one for the routing information is the route leaking. What means the route leaking? At the beginning, the IFC 1195 specifies that integrated ISIS need to treat level 1 errors as special error in the OSPF 1. That means if your router is a level 1 router, like the NAS area in the OSPF, you only know the detailed information about your region is enough. If you want to wait outside, right? If you want to wait outside, you can use the default route from your level 1 and level 2 router. But in your area, if you have multiple level 1 and level 2 router, how to choose the best one? You only use the nearest routing information as our egress router, and then you can use this default route to wait outside. But as we know, if you want to wait from the first router to the last router, you have to consider the whole path cost value. If you only choose the nearest router of level 1 and level 2, maybe there is a less optical route, right? So how to avoid this function? We can have a route leaking. That means it will introduce the level 1 IP routes into level 1 routers. So the level 1 router can calculate the whole path. That means you can think you can redistribute the level 1 routing information into level 2 routing information into the level 1 database. So for the level 1 router, we'll know everything about our whole network. Okay, so the command is like this: redistribute ISIS, and this is IS process number, and the level 2 into level 1, and what's the redistribute list number. And this is a process ID. And by default, the level 2 routing information will not be added into the level 1 database. So you can use this command to let the level 1 router know everything. But pay attention, because you get more information, so your database will be bigger. It will take you lots of resources. So pay attention about this one. And here is an example. If you don't do the route leaking, what's the result? Why we call, finally, maybe you will choose the not best route for your packet forwarding. For example, the same topology, right? Route 1, 2, 3, 4, 5, 6, and 7. And they located in 2 areas. If now the route 2 for this router, if they want to visit the destination 7.7.7 and the 7.7.7 located in route 7, right? In the about route 2, because route 2 is a level 1 router, so by default, route 2 router only knows the detailed information about the area 001. And how to visit the destination in the other area, we will choose the nearest default route, right? Because in your region, you have 2 level 1 and level 2 router. And who gave me the shortest path of default route? I will use this default route to forward the message out. So you will find for this path, the default route cost value is 10 plus 10. It is 20. And for this link, the value will become 30. So as we know, the 20 is smaller than 30, right? So the route to how to visit the 7.7, I will forward it to R1, R1 forward it to R3. And about the R3, this is a backbone area member. So I will directly forward the message to route 7. But as we know about this course, if you only consider the default route, the 20 value is smaller. But if you consider the whole path, the value will become 90, right? 10 plus 10 plus 60 plus 10, it is 90. And for another link, if you choose the link from directly to 40, the default route cost value is 30. But the other link is 10, 10. So finally, the whole cost value is 50. So if you consider the whole path from the source to destination, you can choose the best path on the second path, right? Because the cost value only 50, but the red one, the link is 90. So this is the problem of the route leaking. And how to solve this problem? You can use the ISIS redistribution. You can let route 2 know the whole path and then calculate by itself. So if you want to use this function, you must to redistribute your routing information. Redistribute the level 2 route into level 1. And how to do the redistribution? We have to add some configuration. So the next part, we will go to see the detail, how to add some basic configuration on the ISIS. And now we already know the principle and know how to calculate the routing information in the ISIS protocol. Then let's see some basic configuration. How to add the configuration on the router. Then the router can use the ISIS routing information and to calculate some correct routes. And if we want to add some basic configuration here, there are some key commands you have to know. The first is you have to start the ISIS routing process and then to enter the configuration mode. The command is router ISIS, and here you can add some tag. And of course, you have to give the special process ID. And then you have to set the special net address, and the function is very similar like the route ID on OSPF. And the command is net and gives the net address. And you have to set the level on each router. We have 3 types, level 1 and 2, or maybe level 2 only. The default value of one router, if you enable the ISIS protocol, is level 1 and 2. Okay. And then you have to enable which interface want to use the ISIS protocol. Then this interface can be added into the LSP, and the routing information can be sent to your adjacency. And the next step, you also can change your interface type, maybe to become level 1, or maybe level 2, or maybe level 1 and 2. Which scenario you will use this command? By default, if one router, route 1, to connect with route 2 and connect with route 3, right? If this is a topology. And now if you set the route 1 to the first router to become level 1 router, right? And all the interface you enable the ISIS only will send out the level 1 packets. And about the level, the route 2, if this router you don't change the ISIS router type, this is level 1 and 2 router. And all the interface you enable will send out the level 1 and level 2 packets, maybe like the level 1 and level 2 hello packets. So when I send out the message to route 1 about level 1 hello packets, the first router can give us a reply. I also will send out the level 2 hello packets, but no one will give us a reply, right? Because the first router is a level 1 router. But I will send out the hello packets all the time, try to find our adjacency. So in this scenario, you can change the interface to become level 1. The command is ISIS, the code type to become level 1. And in this scenario, if you connect with route 3, and route 3 is a level 2 router, you can change the interface, connect with route 3 and to become level 2. Also, you can reduce the packets of level 1. Okay. And another one is you can change the network type. For example, if your physical interface only connect with one router, and although this interface maybe is a broadcast interface, you can change the type to become P2P, okay? And this configuration is optional. And another advanced function, like you can configure the route leaking to leak the level 2 routes into the level 1 router. So the level 1 router will get everything finally to calculate the best route information. And the command is redistribute the ISIS with a process ID and the level 2 into level 1. Okay, so this is a basic one. And also you can configure some route aggregation to reduce the size of routing table. The command is summary address, IPv4 address, and what's your net mask and what's your level. Give the IP address and the mask. Okay, so this is some advanced function. If you use the summary function for your router, you can reduce your IP routing table number. And here is one example to you. For example, now we have 3 routers, route 1, route 2, and route 3. And route 1 and route 2 located in the AS49, so 0591, and the route 3 in the other area. And we want to finalize the loopback address of route 1, 1.1.1.1, campaign the loopback address in route 3, 3.3.3, campaign each other successfully. And another is route 1 is level 1 router, route 2 is level 1 and 2 router, and the route 3 is the level 2 router. So in this scenario, how to add the command to meet the requirements. About the route 1, first you have to enable the ISIS function. Router ISIS and the process ID is 100. Because route 1 is a level 1 router, so you can change the route type to become level 1 and give a NAT address, and you can enable the grateful restart. And if you enable the ISIS function, then which interface you want to advertise to a neighbor, you can change the IP router ISIS enable this ISIS function. Also your loopback address. And pay attention, this system ID may be from your route ID 1.1.1. This is your planning from your loopback address 1.1.1, but you still have to add the configuration. They cannot create automatically. And about the route 2, you also have to enable the ISIS and give the NAT address. And then you have to enable 3 interfaces, IP router, ISIS 100, ISIS 100, and also your loopback address 2.2.2 to enable this ISIS process. And if you want to reduce the resources, you can set the physical link connect with route 1 to become level 1 interface. Otherwise, all the physical interface will send out to the level 1 and the level 2 packets, right? But the physical interface connect with route 1. Nobody will give you a reply, give you the level 2 reply. So this is a suggestion. If you don't change the interface type, it also can work. And about the route 3, you have to enable the ISIS routing and set the IS router type to become level 2 and give the NAT address, and then enable your physical interface and your loopback interface. It's very easy. If you add the other service, you only need to enable the ISIS function, it's enough. Then after you add the configuration, then you can check some status. First is you can show your CLNS, your neighbor. This is a key command to check your neighbor relationship. Show CLNS IS neighbor. And in the route 1, you only have one neighbor is route 2, right? And now your status is up. About the route 2, you will have 2 neighbors, and all of them's status will become up. And the route 3 also only have one neighbor with the route 2. The status all of them is up. And then you can run the to check your ISIS database. The command is show ISIS database on the route 1. And on the route 1 now you will have one area. And in the area, all the information here from yourself, right? If you have the special feature in the LSP, that means this one from yourself, the rest from your neighbor. And because the route 2 is level 1 and the level 2 router, so we will send you the special information for the ATT bit to become 1. So you will get a default route. And you can show IP route ISIS to check the routing information. First is the default route 000, right? And this is a default route from your neighbor. And also the value from the segment from 2.2.2 and the physical link. But you cannot get the 3.3.3 segment because you are the level 1 router. And you will use the default route to go outside. Okay, and the route 2 will deliver the default route to you. And in this topology, because route 1 only have one outer router, so you don't need to consider the best path or maybe the optical path, right? But in this topology, you have to consider, because if you only choose the default route according to the nearest from route 1 and route 2. Maybe finally the whole path will not become the best path. So in this scenario, you must use a route leaking function, right? If route 2 want to wait the 7.7.7, finally to choose the best path from route 4 and then go to route 5 and then wait the last router. So if you want to meet the requirement, how to do the configuration? First is you have to provide the basic ISIS configuration. Enables a router, enables the ISIS function, and also enable your physical interface. And also you can set some router type. And there are two paths between route 2 to wait destination 7.7.7. The path A is from route 2, 1, 3, 5, and 7. The whole course is 90. But another path from route 2, route 4, route 5, route 7, the whole cost value is 50. So we hope that the route 2 can select the second path. But as a configuration, if you don't add the route leaking function, maybe the route 2 will choose the first path as the best path. So on the route 2, how to wait the 7.7, right? It will choose the default route. Because the rest of routes cannot help us to follow the message from 7.7. But this link from route 1. It should from route 3. Yes, from route 3. So the cost value is 10 between route 2 and route 1. The cost value is 30 between route 2 and route 4. So the route 2 will choose the default router from our neighbor, our direct neighbor, route 1, right? So if you trace route 7.7 and from your neighbor 2.2.2, the first step will become 9.9.12.1. This is an IP address connect with route 1. And if we add the route leaking configuration on the router, and pay attention, this function must add into the level 1 and level 2 router, because the basic function is you want to redistribute the ISIS process 100 level 2 into level 1. So your router must support level 2 and level 1 at the same time. And this function is you can redistribute the level 2 database into the level 1. So I can transfer the routing information to my level 1 neighbor. Otherwise, by default, the level 2 router information cannot be added into the level 1 database. So your level 1 router cannot get the routing information. And you also can use some distribute list to select which routing information you want to choose. If you don't add this one, that means all the level 2 router will be added into your level 1 database and then told your neighbor. If you add this function, then check your routing table again. The default route still exists, right? That's because you have level 1 and level 2 neighbor. Then you will find a special ISIS routing information here, 7.7.7. And this next hop will be different with the default route, right? Because you, according to the redistribution, you already get the detail of the 7.7. So the 7.7.7 is leaked by the route 4. The path between route 2 and the destination 7.7 becomes the optimal path. So if now you trace route the destination again, you will find who will be the correct next hop. And the only 3 routers you can direct to wait your destination. So this is a basic one. But pay attention, especially when you do the configuration on your level 1 and level 2 router. Suggest to add the distribute list. And according to this list, you can limit the routing range. Otherwise, all the level 2 routing will be added into the level 1. So maybe your level 1 router resources is not enough. If you want to let level 1 router know everything, you can directly change your router type to become level 2. You don't need to do the root leaking. So pay attention about this one. In the last step, you can see some difference and the same feature between ISIS and OSPF, because these are two typical dynamic routing protocol deployed in our network. And the different dividing methods of ISIS and OSPF is OSPF use router as the border, right? So one router can belong to different areas, and the different interface can located in different areas. So this is different. But ISIS are divided by link. So one router, all interfaces must belong to the same area. So this is the first difference about the area setting. And the second one is the backbone area. For OSPF, we only use the area 0 to become backbone. So when your network division, if your area 0 are not connected with each other, you can use some technology like a virtual link to make them logically connect with each other. So this is different. But about the ISIS, depends on the router type. Level 2 and level 1 and 2 router can build our backbone network. So you can use the backbone function, but located in different areas. It is very convenient to make your network bigger. And the similar is both of them belong to the link state protocol and also belong to the IGP scenario. And both of them support the area division and the root hierarchical and are applied to the larger networks, because we can divide the different routes to become different levels. So you can use some tool to control the route information. And the difference like here, the routing protocol encapsulation, ISIS directly encapsulate into the data link layer, but OSPF encapsulate into the network layer. And the ISIS can support IP and non-IP protocol, but OSPF only can support IPv4 protocol. And the complex, ISIS has less LSP, and normally one area is used. And about the OSPF, we have lots of LSA types, and normally multiple areas are configured. And about the scalability, because ISIS support a single large area, and we can have the TLV architecture. So if you want to add lots of features in the ISIS, it's very convenient. And about the OSPF support for a large network, which is normally divided into multiple areas. So these are difference between the ISIS and OSPF. And there are some questions. Which of the following statements about ISIS are wrong? This is a multiple choice. The first one, ISIS runs directly on the data link layer. Option B, the ISIS backbone area is the set of continuous level 2 router, includes the level 1 and level 2 routers. Round 3, option 3, DIS is ISIS. In ISIS is very similar to the DI in OSPF. DIS selector is in non-pre-option mode, and there is a backup DIS. This option is wrong, right? Because about the ISIS, this in the preemption mode. In every time we will select the highest priority router to become DIS, and there is no backup DIS. So option D, ISIS use the SPF algorithm that runs in the separate level 1 and level 2 database. It is correct. Option E, level 1 and level 2 router in the network always delivers the default route to level 1 routers. So option C is wrong. Option E also is wrong. Only the level 1 and level 2 router in the same network with level 1 router, we will send out the default route, right? So this is the first question. The second question, which of the following statements about ISIS route leaking are correct? Option A, if there are multiple level 1 and level 2 router in the ISIS network, and level 1 router will randomly select an level 1 and level 2 router as an area traffic egress. So this is incorrect, right? We will choose the nearest level 1, level 2 router to become the egress router. So option B, the rise of ISIS route leaking is because level 2 routes cannot be released to level 1 router. This option is correct. By default, we don't support level 2 routes into the level 1 router. Option C, a level 1 router may have a less optional path because it randomly chooses a level 1 and level 2 router as the area traffic egress. So option C also is wrong. The same reason with option A, right? And option D, if there are multiple level 1, level 2 router in an ISIS network, and level 1 router choose the nearest level 1 and level 2 router as the area traffic egress, that may result in less optimal paths. So option B and option D are correct. So here is a summary for ISIS. First, ISIS is dynamically routing protocol designed by the ISO organization for OSI reference model at the beginning. And similar to OSPF, ISIS also use SPF algorithm to create a loop-free topology. Okay, and the detail, some feature will be difference between the ISIS and OSPF. And we also have an introduction, what's the difference? And this point use a configuration example to describe the ISIS basic and also the backbone issue solution and what's the result of the route leaking. So in your network, especially in the region, for level 1 router, you have multiple choice of level 1 and level 2 router. Maybe there is a less optimal path. So in this scenario, you can consider to use the route leaking function to let your terminal, level 1 router choose the best path. But also consider if you redistribute level 2 routes into a level 1 router, maybe the level 1 router performance is not so well. So please also consider about this one. That's all. Thank you.